So you're welcome to class again. So we are looking at a new topic, theory of logarithm, and our attention in this class is to look at the laws of logarithm and also to solve some questions based on the laws of logarithm I'll be showing you today. So let's go from here. Log, I want to discuss the part of a log first. So if I have log, and I have a number down here, another number here, then I have b here. Let's say this is also a number. All alphabet represents numbers. So this is called base. Base. So we call that the base of the logarithm. Why this is called the argument. Argument. And lastly, what we have here as b is called the exponent. Exponent. So these are the parts of a logarithm figure or a logarithm expression. Let's say logarithm expression. So we go on from here to talk about the laws of logarithm. So we talk about the laws of logarithm. The laws. Now, the first law says we have log base a m times n. Since we have a base a here and two numbers are being multiplied or two variables are being multiplied here, this will be simplified as log base a m plus log base a n. This is how we simplify multiplication law. So this is how we simplify multiplication. That is, the log will be shared to the two numbers that are being multiplied, and in that process they will be added. This is the version of the law is a version of the law of logarithm that is similar to the law we have in indices, which says that x raised to power m, or let me use a, because our base in the logarithm is a. In indices, if I have a raised to power m times a raised to power n, it will be equal to a raised to power m plus n. So as far as the bases are the same, the power can be added in this form, and that is the same thing. That was the same thing we have here. As far as the base, we have a base, so we can share the base y to each of the values multiplied, while the two will be added. So we go to the second law. The second law, which is the division part of the law. The, so if we have division, we use subtraction to evaluate division. So we write the log and its base. The base will be the same on both sides. Why? They are subtracted. And this law is the one similar to the law of indices. We say that a raised to power m divided by a raised to power n is equal to a to the power of m minus n. The third law, I call this the power law. If we have log a m raised to power of n, the power can turn to coefficient. So this power becomes coefficient. So you turn to the coefficient log a m. This is the simplification for this. The fourth law. The fourth law talks about the base and the exponent. When the base and the exponent are the same, the answer is equal to 1. So if we have log 2 base 2, the answer is equal to 1. And if we have log 10 base 10, the answer is also equal to 1. Now, number 5, the fifth law. If we have logarithm of 1, if we have 1 with any base, when the argument is 1 and the base is any, let's say 10, 3, 2, whatever it is, the answer is equal to 0. The answer equals 0. Another very important law, which is very important for simplification at some point. So when the base carries a power, let's say the base carries a power x, and we have m here, and the base carries a power x and we have m, the multiplicative inverse of the base will become the coefficient. That is, the power in the base will become the coefficient, but not just the power in the base, the multiplicative inverse of the power in the base. For example, the multiplicative inverse of 2 is a number that will multiply 2, and the answer it will give is 1. A number, multiplicative inverse, let me talk about that briefly. Multiplicative inverse. So it's a number that will multiply 2, and the answer after the multiplication has been carried out will be 1. So what number will multiply 2 that will make the answer 1? That is 1 over 2. So for example, the multiplicative inverse of 2 is 1 over 2. The multiplicative inverse of minus 3 will be minus 1 over 3. Minus 1 over 3. Because we want to get positive 1. So we need to introduce a negative here, so that the negative will multiply the negative and we have positive. The multiplicative inverse of minus 3 over 4 is minus 4 over 3. When these two multiply each other, the answer is 1. So that's multiplicative inverse. So the multiplicative inverse of x is 1 over x. So the multiplicative inverse will become the coefficient. So it will be 1 over x log m base a. So what if a case occurs where the argument carries a power and the base also carries a power has a power. Both has a power. We can evaluate anyone first, like we have initially said. The base of the argument becomes the coefficient. So, and the base of the argument here is y. So that will become the coefficient. So we have log y log m base a raised to power x. Now, with the sixth law, we also explained that the power of the base, the reciprocal of the power of the base, will become the coefficient. The reciprocal or multiplicative inverse of the power of the base will become the coefficient. So that means x will also become coefficient, but the multiplicative inverse of x. And the multiplicative inverse of x is 1 over x. So we have y times 1 over x log base a log m base a, which can be written as y over x log m base a. So that is that. So we'll look at some questions now. We'll look at some questions. So let's look at this question. We have log 54 base 3 log 6 base 3 minus log 4 base 3. So all carries the same base. So what do we then do? Since they have the same base, that means the first law and the second law is applicable here. Where we said the first law, I will write it so that we can apply it properly. Log a m times n is equal to log m base a plus log n base a. That is, if two values are being added, if two values are being multiplied, it can be written in this form. So this law can go like this, and it can also go this way. So if we check what we have, it's in this format. What we have here, it's in this format. So we interpret it like this. So since it is addition in between, and we have addition here, and both carries the same base, and the base is 3. So this can be interpreted as log base 3 54 times 6. So I've interpreted this minus log base 3 4. Now from here, we have another law which has to do with division. Log a m over n is equal to log a m minus log base a n. So we will also interpret this in this format. We will turn subtraction to division. Now we will do that. It will become log base 3, since they have the same base, 54 times 6 all over 4. So we will evaluate what's in the brackets with calculator. As we know, 4 can divide 54. 4 can divide, okay, let's break it a bit. 2 in 4 is 2, 2 in 54 is 27, and 2 is 2 is 1, 2 in 6 is 3. So we are left with log base 3, 27 times 3, which is log base log 81 base 3. So to finish up the question, we try to simplify it further. And simplifying this further, we need to check if 81 can be expressed as a power of 3, so that I have the same number here and here. If 81 can be expressed as a power of 3, and it can. So we then have log 3 raised to power 4. 3 raised to power 4 is equal to 81 base 3. So that's what we have. Now we have another law that speculates that that says that power can become coefficient. So if I have a power, I can bring it as coefficient, which will become n log am. So if I do that to this, I will have 4 log 3 3. 4 log 3 base 3. Now, there is a law that also says that when the base and the arguments are the same, the answer is equal to 1. That implies everything here in the box is equal to 1. So that means we have 4 times 1, which is equal to 4. So we look at another question. So we look at this question. We have simplify log 8 plus log 4. So when the base of the log is not written, like the question we have, there's no base at all, it implies that the base of the log is 10, which is the standard base of logarithm. So when the base is not written, the base is 10. So we use first law, as we can see. We use first law can simplify the numerator, while second law can simplify the denominator. And first law says that if two logs, we have two logs with the same base being added with it can be multiplied. So we have log 4 times 8, and for the denominator we have log 8 divided by 4. So I will change what I wrote here so that it's written the same way the question is. So So we have 8 times 4 here, which is log 32. Let's have this in the bracket. Then for the denominator, log 2. So I will look at how I can simplify further. And how will I simplify further? 32 can be expressed as a power of 2. So let's do that. If I express 32 as a power of 2, I have log 2 raised to power 5 over log 2. So we apply the law that says power can become coefficient. Power can become coefficient. So we bring the power 5 to become the coefficient. So we have log 5 log 2 all divided by log 2. So from here, log 2 will cancel out log 2, and our answer is equal to 5. So that's the second example. So I have another question here. Simplify a raised to power 1 over 3 base 10, 1 over 4 log a base 10, minus 1 over 12 log a base 10. So the first law I will apply here is that I need to take all the coefficients to become power. We have initially established that power can become coefficient. Power can become coefficient. So we can bring power to coefficient. So we have n log m base a. So the same way this can be interpreted in this form, it can also be interpreted in this form. For the second variable, which is 1 over 4 log a base 10, it's in this form. And the same thing is applied to the last variable, which is 1 over 12 log a raised to power 7 base 10. So we can interpret it, take the power in the coefficient to the coefficient, take it to the power of the argument. So that would not affect the first variable because the power is already the argument already has a power and there is no coefficient there. So we have log a raised to power 1 over 3 base 10. So I'm taking the coefficients to become the power of a. And we have log a raised to power 1 over 4 base 10. Then minus log a raised to power of 7. So another power is coming, times 1 over 12 base 10. So from here, I can apply the second and the third law, which says when we have addition, it can turn to multiplication, and when we have division, when we have subtraction, it can turn to division. If all the bases are the same, and the bases are the same here, we have base 10 throughout. So I would then have this a raised to power 1 over 3 a raised to power 1 over 3 times a raised to power 1 over 4, all divided, because we have division over there, by, if I multiply this, 4 times 1 over 12 will give me 7, 7 times 1 over 12 will give me 7 over 12. So it will be divided by a raised to power 7 over 12. Close the bracket. Now, we simplify what we have here. If we simplify that using laws of indices, when we have multiplication, the power can be added. And when we have division, the power can be subtracted. So we have log, open brackets, we have base 10, a to the power of 1 over 3 plus 1 over 4. The power can be added when we have multiplication as far as the bases are the same. And the power can be subtracted when we have division, minus 7 over 12. So, close the brackets. So if we simplify 1 over, I want to simplify 1 over 3 plus 1 over 4 minus 7 over 12. So using addition and subtraction of fractions, my LCM will be 12. So I will have 4 plus 3 minus 4 plus 3 minus 7, which is equal to 0 over 12. And 0 over 12, 0 divided by 12 is equal to 0. So the answer here will be equal to 0. So that will be our answer. So that means all the power there, all the power of A here is all 0. So we then have log A raised to power 0 base 10. And A raised to power 0 is equal to 0 by indices. Anything raised to power 0 is equal to 1, anything raised to power 0 is equal to 1. So we have log 1 base 10. And I told us when we have any base and we have 1 here, any base with 1 here, the answer is equal to 0. That means our answer for this question is 0. Look at this example. The A question there says simplify 1 over 2 log 25 over 4 base 10 minus 2 log 4 over 5 base 10 plus 320 over 125 plus log 320 over 125 base 10. Now this is a GC equation, and it's very, very easy to simplify. So we can apply first law and second law to this question based on the fact that the questions carry positive and negative signs. But we have to look at the fact that the first two variables have a coefficient, which is 1 over 2 and 2. So the 1 over 2, we will turn the coefficient to a power, as we have a law that says that. Let's look at it. We have 1 over 2 log base 10 in brackets 25 over 4 minus 2 log base 10 in brackets 4 over 5 plus log 320 over 125 base 10. Now, let's carefully look at this. We have a law, like I was saying, that imply we can turn coefficient power into coefficient. So the power here becomes coefficient. So we can have n log m base x. So the same way we can turn power to coefficient, just like we did. We simplified this in this form to become this. We can also simplify in this form, because if we check the first two variables we have here, they both carry a coefficient of 1 over 2 here and coefficients of 2 here. So we can take both coefficients to the power of the argument. You can take both coefficients to the power of the argument. Don't forget, I told us that the argument is the number here. So let's do that. Let's apply this law for that. So we then have log base 10 25 over 4. So the 1 over 2 will become a power of 25 over 4 minus log base 10 4 over 5. Then the 2 will become a power of 4 over 5. Then plus log base 10 320 over 125. So from here we simplify. In our simplification, we can use different methods to simplify this. For example, um, 25 over 4 raised to power 1 over 2 is the same thing as square root of 25 over 4. Now, how did I get this? There's a rule in indices that says, let me write it, that says that when there is a fractional power, just like we have here, a raised to power m over n, that the denominator of the fraction becomes the root, while the numerator of the fraction becomes the power, like this. So the numerator will become the root. That's why I have root n of a. Then the numerator will become the power raised to power a. So if peradventure we have 9 raised to power 3 over 2, it will be square root of 9 raised to power 3. So, but the denominator here is 2, that is square root of 25 over 4, while the numerator is 1. Anything raised to power 1 will still be the same. So that's why I didn't write any 1 here. But this is a law of indices for fractional power. The denominator of the fraction becomes the root. So the answer here will become 5 over 2. So from here we have log base 10, 5 over 2, log 5 base 10. Minus, we can apply this power to the two of them. That will be 16 over 25 plus log 320 over 125 base 10. So from here, we go ahead to apply our first and second law. Our first and second law implies when logarithms have the same base, if they are subtracted, we can write one of the logarithm base and divide. And if they are added, we can just write one of the logarithm base and multiply the argument. So that's what we'll be applying here. So they all carry the same base. The three of them carries the same base. So I will just write one of the logarithm with its base. Then in my brackets, for the first two, they are dividing each other. So we have 5 over 2 over 16 over 25, then times 320 over 125. So for subtraction, we divided. For addition, we multiplied. So now, we have we'll change the division to multiplication. So we have 5 over 2 times 25 over 16 times 320 over 125. Then we divide appropriately. 25 can divide 125 5 times, and 5 we take out 5 here. 16 can divide 320 20 times. So we are left with 5 over 2 and 20 over 2 in the bracket, 20 over 2, which is equal to 10. So we then have log 10 base 10. And when the argument and the base are the same, when the argument and the base are the same, the answer is equal to 1. So the answer for our simplification is 1. So we have answered question A. We go ahead to question B, which says log 3 over 8 base 10 plus 2 log 4 over 5 base 10 minus log 6 over minus log 6 over 25 base 10. So that is our new question. So I'll copy it here. Log 3 over 8 base 10 plus 2 log 4 over 5 base 10 minus log 6 over 25 base 10. This kind of simpler compared to the one we just did, so we might not spend so much time on it. So log 3 over 8 base 10 plus 2 log 4 over 5 base 10 minus log 6 over 25 base 10. So let's go ahead to solve this. So like I said, for this kind of question, they have the same base and we have addition and subtraction in between. We just check if there is any coefficient that can become power. So we make coefficient power and we have one like that here. So we make the coefficient power. We have log 3 over 8 base 10. Then we take 2 to the power. Then we have log plus log 10. 2 will become the coefficient of the argument, that is of 4 over 5 minus log 6 over 25. Log 6 over 25 base 10. So from here, we can simplify that. We have log 3 over 8 base 10 plus log. This will become 16 over 25 base 10 minus log 6 over 25 base 10. So we apply our first and second law, which implies that addition, when they carry the same base, can be written with one base while the argument is multiplied. So the argument 3 over 8 will multiply the argument 16 over 25. And when we have subtraction, the argument can be divided. So we divide with the argument 6 over 25. So from here we have log of 3 over 8 times 16 over 25. Then we change division to multiplication while the fraction will be reversed. So 6 over 25 will become 25 over 6. So from here we divide. 25 can take out 25. Then 8 can take out part of 16, it will remain 2. 2 can take out part of 6, it will remain 3. And 3 can take out 3. So there's nothing left. That means we have 1 left in the bracket. So we have log base 10 1. And it is one of our rules that when we have 1 in the argument and any number in the base, any number at all, the answer is equal to 0. So the answer to this question is 0. So we move to another one. So let's solve this. 2 minus log 25 base, argument is 5, log base 25, and the argument is 5. So what we do here, we have 2 minus, we change the base to a power of 5 so that there will be similarity between the argument and the base. So instead of leaving it as 25, we change it to a power of 5. So I have 5 here. Then I will have 5 raised to power 2 in the argument, because 25 is equal to 5 raised to power 2. There is a law which I've been explained where I said if the base carries a power, let me use an alphabet here. If the base carries a power, the power in the base, the inverse of the power in the base will become the coefficient. So if I possibly have A over here, then I have B raised to power x. Then the inverse of x, the inverse of x is 1 over x. The inverse of 2 is 1 over 2. The inverse of 3 over 2 will be 2 over 3. The inverse of minus 1 over 2 will be minus 2. So let's take note of this. Minus 2. Let's take note of this. So the inverse of x is 1 over x. The 1 over x will become the coefficient. So become the coefficient. So we have 1 over x log a base b. So here, the 2, which is the power here, will become coefficient, but only the inverse of 2 will become the coefficient. So we then have 2 minus 1 over 2 log 5 base 5. And when the argument and the base are the same, the answer is equal to 1. So therefore we have 2 minus 1 over 2 in brackets 1, which is equal to 2 minus 1 over 2. Our answer is equal to 1 1/2 or 3 over 2. So that is the answer. So this will be our last example. Very simple question. So we have log square root of 5 divided by log 5. So like I said the other time, I was saying something about fractional power, a raised to power m over n. I said the denominator of the fraction will become the root, while the numerator will become the power. So we can simplify in this way. We can also simplify this way. So if I have a root, I have a square root, cube root, fourth root, I can turn it to fractional power. Just like I have a root 5 here. So I can turn the root 5 to a fractional power. So if root 5 will become a fractional power, square root is 2. So we have log 5 raised to power 1 over 2. So 5 raised to power 1 over 2 is the same thing as square root of 5 divided by log 5. So after this simplification, power can turn to coefficient. That's 1 over loss. So we have 1 over 2 log 5 all divided by log 5. So from here, log 5, we take out log 5. Therefore, the answer is 1 over 2. So this is logarithm. So in this class, we have solved JAM questions, WIAC questions, and what we had before, which was a polyjump. So we have solved all of this. Polyjump is PC. The last one we did is a polyjump question. So with this is the initial aspect of theory of logarithm. So there will be further videos on this. If you have any question, I'll put it in the comment section. I'll be there to answer your question. This is Sam, the math tutor, and I absolutely appreciate that you stay tuned. Thanks.